Recording in progress, thanks to the nice robot lady. So today we are going to be dealing with glass. We dealt with reflectivity, reflective objects. Well, let's just do this. Move this up here. Not enough real estate on a screen ever. Okay, so today we're dealing with reflectivity, transparency, and refractions, transmission and refractions. We dealt with reflectivity only on Friday when we dealt with the reflective part of the material, and we dealt with metal. Today, we're going to be dealing with glass, which is a little bit reflective, but mostly transparent and transmissive and refractive, all three of those. So there's a slight difference between just being transparent and being transmissive. Okay. So office hours tomorrow will be 10 to 4, 10 to 4 on Thursday. Frank will be doing the open lab for campus and online students. Optional, of course. It is from 1 to 5 p.m. Eastern Standard Time. Just a reminder, no campus lectures on Fridays in May. We're just doing the virtual Zoom lectures. So transmission, refraction, transparency, something called the index of refraction, which we dealt briefly with in the reflective area. The default index of refraction in the specular section of the material is 1.5, which is set for glass. 1.5 works for a lot of different materials. You saw that when we increased it to, there was a preset plastic, it went to 1.55. Slightly more reflective. And light will behave differently on a surface that is a little considered, I guess, to be a little denser. And it has to do with the Fresnel reflection, how we view things at different angles and what happens with that viewing angle. We talked about walking out to the water. You look down, you can see through the water at your feet, but as you start to pick your head up towards the horizon, the water gets less transparent and more reflective. So don't forget, tomorrow is when Project 6 is due, the material discussion, and also your research discussion. All right, any questions about anything we went over previously before we get rolling into the transmission and refraction? So Tamari's good. Anybody else? Cody's good. Thank you. Marissa's good. Josh is good. Thank you. Miles, Patrick. Miles is good. Diamond's good. Thank you. Javier, Tiana, Craig, any questions? Patrick is good. Okay, thank you. Tiana's good. Okay. All right, so when we talk about transmission, we're talking about light passing through a subject, and depending on what that subject is, it will behave accordingly. Now, air is probably the easiest substance for us to understand how transmission works. So most of the time, if there are not too many water particles or pollutants, dust, pollen in the air, light will usually pass through air unobstructed, meaning it's not altered in its course and it does not deviate from its path unless it hits another surface. So when light passes through a subject that's clean, clear, that is called transmission. Now, on a hot, humid day here in Florida, you could look out at the parking lot and you could see waves where the moisture particles are heated and consequently they're rising and falling. And that kind of distorts our vision as we look through it. That's a different case. That is something along the lines of refraction. So when light rays hit a surface, and here's the interesting part, for the most part, light, depending on the light source, can be omnidirectional. For example, could hold a bare light bulb in here. And our air is fairly clear in the room here. And what we would see is a lot of illumination in all different directions without light being deviated at all. So when light passes through a surface at a perpendicular angle, and if the air is clear, that perpendicular angle could be any direction because the air molecules are so small. As long as it passes through at a perpendicular direction, which means it hits the surface at a 90-degree angle to its origin and passes through unobstructed, that is transmission. So we could do it with a super clear piece of glass, like optical, surgical quality. Thin, clear, light hitting it perfectly perpendicular, light will go through. You won't be able to see any deviation. But as soon as that light ray hits at an incident angle being anything other than 90 degrees, it could be, hitting the surface at 90, it could be 90.000001. It's going to start to bend as it passes through that same piece of glass. So as the angle changes more, the light rays will deviate on their path even more. So the bending of light rays as they are transmitted from one material to another is called refraction. It's still being transmitted. Light's being transmitted through the air. It hits a surface, it gets transmitted through that surface. And if that surface is glass, it's clear, it will continue on its way, but at an altered angle. So pretty simple actual physics, but it's just something that we want to establish the difference between. Because depending on, I hate to say the word, optics, how we look at things, that's going to depend on what we want out of our glass. So when we have a glass sitting on a table with light rays coming in at an angle, we expect to see, refraction, things distorted when we look through that glass. So I have a water bottle here. So if you look through the water bottle, everything looks pretty distorted. One, I've got plastic. Two, I've got an area where there's liquid. And three, that liquid is cooled and it's colder than the air. So consequently, I have this kind of hazy mist on the side called condensation. So all of that is helping to distort, each layer of that is helping to distort the light rays as they try to pass through. All right, does that make sense? Questions? Okay, Tamari's good. Thank you. All right, good, good, good. Okay, so let's take a look at the next slide. The next slide is going to kind of lead me into opening in a simple scene in Maya that I have set up to kind of explain how it works in Arnold. But we have you guys model objects like they exist in the real world because we need to account for the material properties that we're going to assign to a piece of geometry. And we want it to have the same depth, the same thickness, if you will, of the real world material. And our materials say, hey, that's a piece of plastic, that's a piece of glass. If it's a piece of plastic, is it transparent? No, it's going to bounce off. If it's transparent, it'll pass through. What's the index of refraction? It will bend accordingly. So now you guys have all built something very similar to this wine glass, right? Simple, you do a CV curve, follow it around the profile, you do a revolve poly output, pretty much done. Now, like I said, the reason we have you go up and around the profile is because this area right in here, this area right here, that is our material. That is our material property. So if it's ceramic, it's going to be reflective. If it's glass, it's going to be transparent. It may transmit some light rays, but it's probably going to refract more light rays than it's going to transmit. So in our case, this is glass. All right, so we've got a light ray coming in. It hits that surface of the glass, and immediately it has to query the glass. Query that material, because right now it doesn't know what it is. It's a piece of geometry. All right, so piece of geometry, what's assigned to you? Okay, well, I'm glass. My index of refraction is 1.55. So the light ray will go into that glass, bend according to the index of refraction, and then exit the inner wall of that piece of geometry. So what is inside the middle here? What's inside here? Anybody? Air. Yep. Not a trick question. Air. Index of refraction for air is 1.0, which means it's very neutral. So the light rays will now transmit through that area. So they will basically go back into a path that makes sense after exiting the glass and continue on till it hits the inner wall on the other side. Now, having short-term memory, the ray goes, hey, what are you? Because the ray is only concerned with what's happening at the moment. It has recorded all that other information. It doesn't keep a database going, oh, well, you're connected to this piece of geometry. No, it doesn't care. It's just going through on its path. So it hits the wall of that surface. What are you? Hey, I'm glass again. All right, so it will again bend according to the index of refraction and exit out. Outside of the glass, presumably air again. So pretty neutral. So a lot of times our rays, which we don't even think about, they're passing through, even though it's CG and technically it's a vacuum, it's treated like air. Anything that a light ray is not hitting is considered to be air. It is transmitting in a path that's not going to make it deviate until it comes in contact with something. Now, if you're doing a particle simulation and you're doing a fluid simulation where, hey, I've got air, but I've got tiny microparticles of moisture in there, well, every once in a while, some of those light rays are going to hit one of those moisture particles, and it's going to, bend as it goes through and do its natural thing. But for the most part, neutral. So what does this mean for us? Well, we've got to keep track of how many surfaces that ray has to go through. So we've got an entry point here. We've got an exit point. That exit point is an entry point to another area, which is air. Okay, it hits the inner wall, goes through, exits the outer wall of the geometry, and continues on its way. So entry, exits. How many points do we have? 4. Yep. For an ordinary drinking glass, we have 4 points. So that means technically our ray will go through it with no problem. Now, if we have a glass in front of a glass, and this is all based on camera visibility. Remember, when we render, we are using what is called path tracing. Path tracing means it's only concerned with what the camera can see. So if the camera can't see overlap in glass, it doesn't calculate it. It's only concerned with what the camera can see. So if we have a glass in front of a glass, how many surfaces would our ray have to go through if it's overlapped in the view of the camera? 8, exactly. Does that make sense? Now, here's another point. What happens if, change colors here. What happens if we have a liquid inside the glass? Why? Why 2? Good. So that shape is considered a solid. So if you were to take that water, freeze it in the glass, be able to dump it out, it would look like the shape of the glass. It would be solid. So water filling a glass, the area and volume that it takes up is considered to be a solid. So our ray would hit the water immediately after exiting the inner wall, hit the water, continue to bend all the way through because it is now water. Water has an index of refraction of 1.33 or 1.3, somewhere around there. Depending on your software package, it will change. It will bend, exit that water shape, immediately hit the inner wall of the glass, go through the glass, exit the outer wall, and then back on its path. So with water, we have 6 entry-exit points. Okay, great. Big deal, right? So what? Well, guess what? That means something for us when we actually go to render. So let me see if this will help. Let me clear all this. Let me fire up Maya. And I've got a scene where I took the wine glass in the exterior scene, brought it in, simple background, sort of like what I have here, my photo on the left with the wine glass. Okay, just to be able to show you what happens when we don't have enough default rays for reflectivity or transmission. And come on, Maya, you're supposed to load. There we are. All right, so wait for everybody to load. Renderman, and then Arnold. All right, there we go. All right, so let me set my project, just have a really simple scene. Like I said, all right, so let me take my objects here and let's get rid of everything, or let's hide everything except a simple wine glass. So all I have here is simple seamless background like we had for the still life, simple point light behind there. And what I want to show you is what happens if we do not have our render settings set. All right, so that's perfectly fine. So we have a couple things to worry about today. One is the sampling for transmission. We talked about specular last time. If you see noise in reflected areas, you're going to have to increase that specular probably from 2 to 4, maybe 4 to 6. It depends on the level of noise, what you're getting. Transmission's the same way. You might not have noise in the reflective areas now, but any areas that you can see through, there might be a little noise. Again, that might be due to too few samples for transmission. So then we have ray depths. Now, the default ray depths kind of contribute along with global illumination. So you see the total is set at 10. Now at 10, that means it will continue to allow anything underneath here to continue to show through and bounce off of until it reaches that top number. Now, so I'm going to leave these settings as they are. And let's see what happens when I've got simple wine glass. And for this, I've already got the glass material assigned to it. All right, so there we are. Now notice transmission is automatically set at 8. Some software packages will set it at 4. Now, if I lower this to 4, you're not going to see a difference. Watch what happens if I lower it to 3, though. Now, I can see through it, but I can't see through that back wall. So what it's doing is it's allowing my camera ray through the first 3 surfaces and then stopping at that back wall. So if I truncate it even more and say 2, it looks a little flatter. I could say 1. And now I can't see through it at all. So at 4, I can see through it completely. Does that make sense? All right, now I've got another surface here. I'm going to throw in my other wine glass. There we go. So now at 4, you can see where the wine glasses do not overlap. It looks perfectly fine. And here's another common problem. You know, a lot of people starting out in this forget that, okay, by itself, 4, you can see through. You can see through 4 the other side, but where they overlap, you don't have enough rays for the camera to go through. Rays are sort of like saying, hey, these are the points you can go through. So I could hit 5 here. I can see through a little bit. I could hit 6. Can see through a little bit more. You can see it kind of creeping down at the bottom. If I hit 8, now I can see through all the glass. Now, specular you generally want to have your specular, when you're dealing with glass, kind of match the level of reflectivity with the transmission, because you want light to bounce around inside your glass. You want it to bounce off your glass and continue to bounce around. So honestly, when you are dealing with, let me save this and we can compare. Well, let me put that back to 1. Good enough. Let's put this at 8. So now you can see the edges of the glass with reflectivity or specular just at 1. You can see it looks a lot darker. You can see under the glass, now we're starting to get a little reflectivity onto the environment. Now, here's the downside. Looks great. Do you get anything for free in Maya? No. So consequently, what this means is longer render times. If you guys haven't noticed already, once you start adding shiny materials, it's going to take longer to render. Now we're adding glass, metal, shiny materials, color, longer render time. Keep your settings low while you are working. And then for your final render, come in here and make sure you have enough rays and enough samples to get a good clean render, and you can see through and bounce off light for all you're seeing. Now, if I turn up diffuse, no, let me put that back to 1, because I really should have a control. That's good enough. Let's take diffuse up to 8. That's kind of dangerous because that will really, really, really increase your render time. And I'm not seeing any real benefit for doing that. So I'm going to keep my diffuse at 1. All right, so in here, let me kind of mark this up a little bit for you. So in here, you can see there is more noise than outside here. And again, that has to do with your specular and your transmission samples. So if I want to clean that up, I've got to go and crank those settings up. Now, I wouldn't recommend cranking them up to 8 because remember, these samples are multiplied by the camera. And usually the camera's turned up for maybe 6, and then all the other settings multiply off of it. All right, but does that kind of make sense about keeping track of the rays, why things would fail? Now, that would also happen if we had, say, a mirror in front of a mirror. You know, if you hold a mirror in front of a mirror, you kind of get those infinite reflections, Hall of Mirrors effect. Okay, but in CG, we have to count every reflection. So we have to get it to a point where it gets so small, that reflection, that we don't care anymore. So lots of stuff that we got for free in the real world, and not so much. Marissa, you said air or liquid. What was that in reference to? Oh, right. Gotcha. So right now, I've got air in the glass. Now, if I were to turn on, I've got some surfaces for liquid inside. So if I turn those on, which I've got them set to be water, well, you can see I got a lot of dark going on there. So I can see through at 8, I can see through pretty good with the water in the glass, but I can't quite see through both glasses with the liquid in it. So we already decided how many surfaces does a ray have to go through for the liquid by itself? How many additional surfaces? 2, right? It's just an entry point and an exit point. It's dealt with as a solid. We now have 2 liquid surfaces. So 8 is good for 2 glasses that are empty. What would we need to have for 2 glasses that have liquid in it? 12, yeah. So then we're talking about cranking up transmission to 12. We're also going to need to crank up our transparency depth to 12. And we're probably going to have to change our total to 12 as well. So let me put them back to 10, just so we can kind of see what's going on. And then here we did 8, 8, 10. So now we have to go to 12. I want my spec. I want it to bounce around as much. Now, I still have some black on the sides. That's because there's nothingness in Maya outside of that seamless background. Right? Nothing on either side. It's not like they're in a bowl or anything. They are just there with nothing on the sides. All right, questions about that? Make sense? Okay. How about out there in the zoomosphere? Any questions? Okay, Tamari's good, Joshua's good. All right, so no, I don't want to save anything. Let's do all this. How did I add liquid to the glass? Well, that's in there already, Miles. Like I said, I took the glass and the liquid in the glass from the outdoor Zen garden scene and imported it into a plain scene with a seamless background. So it's there for you guys already. And in fact, that's what we're going to talk about today, is assigning the material property to the wine glass in the Zen garden and also to the liquid inside there. Now, you guys taught how to model liquids in the glass? No? Generally, I mean, whenever I've taught it, it's always been you select the faces, you can select the internal faces, duplicate the faces, scale them in ever so slightly and kind of cap it off. And with water or any liquid, there's surface tension, tensile strength on the side of the glass where the water is kind of pulling away from the glass, so it's not a perfect level. It kind of looks like that on the sides as it's coming off the glass. So you don't have to put as many holding edges on that top when you cap it off. You just want a few in there so it looks normal. And then just make sure you don't have normals facing the wrong direction. But that's generally the simplest way to do it, because that way your liquid will conform to any shape that your glass is. All right, so let's continue on. So we are still dealing with the conservation of energy. So we talked about diffuse and specular. When we start to add specular, we're stealing from diffuse. When we're dealing with metal, it's all specular or reflective. When we're dealing with glass, it's all transparency, 100%, and a small level of reflectivity. Well, what is that level of reflectivity? Well, it could be anywhere from, 10 to 20%. I'm just throwing a number out there. Remember, glass is never as reflective as it is transparent. So we're still dealing with 100%. So that probably means this is something like 80%. This is probably 20, plus or minus. So here's our index of refraction, automatically set up for glass, piece of cake. Our specular weight, there's our color. Since we turn off the diffuse or the base material, all color comes from the transmission color for glass. All right, so the specular and transmission controls are meant to work together. On some software packages, they have a separate glass section, which means that it overrides any transparency or any specular section. In Arnold, in V-Ray, you work with the specular and transmission separately. Now, you can alter the amount that it's set to work, but generally, to make glass, we turn our base weight off to 0, keep the specular weight at 1, keep the color at 1 or white, keep the index of refraction at 1.5 because that's glass already. We turn up the transmission weight all the way, adjust the color, and that will give you basic, transparent, simple glass. Now, the trouble with doing that, though, is Arnold does not quite get all of the properties of a transparent shadow correct. So we add in a couple of what are called Maya utility nodes to correct that shortfall. And I'll show you what happens when we don't do it versus when we do it. And that is always easier to see when we're outside in the Zen garden, because then you got direct sunlight. Everything is set up pretty, pretty normally like it would be for a normal scene. All right, so specular weight controls the amount of reflectivity. Set it at 1. The index of refraction will take care of how reflective glass should be once you turn up transmission. They work together. Specular color, always keep it white. Specular roughness adjusts how the reflected rays get dispersed or diffused. Remember, we talked about how reflective is it, how rough is your material, and what color is it? Well, that roughness is all about reflectivity in the specular section. And as I mentioned, index of refraction, 1.5 is set up for glass already. Water's 1.33. Wine is going to be slightly different. Alcohol is going to be slightly different, depending on your liquid. So here's an example of what specular roughness looks like only. Transmission weight. The two Maya utilities that we use to correct Arnold's shortfall on creating a proper shadow, it's called a gamma correct and a sampler info. They control the shadows and the appearance of the shadows when the glass is rendered so it looks natural. Transmission color, this is how we add color to glass, add color to liquids. So for today, it's not just glass we're making, we're also making liquids. Transparent liquids. We're not dealing with anything that's kind of specialty like milk or, anything that has some transparency, but it doesn't allow all the light to get through. So there is another roughness setting in transmission that's called extra roughness, and this will disperse the transparent rays, how they disperse or scatter as they're going through. That's the roughness of the glass itself, frosted glass. Ideally, to get the most accurate results, you use a little bit of specular roughness and a little bit of transmission roughness. So then it kind of looks like my bottle here, where I've got a lot of condensation on the outside because the liquid is cooler than the air. So again, here's specular only. Here is transmission only, and then both together. Now, if you've got a glass by itself with nothing in it, and it's a frosted glass, you would just use transmission. Maybe. Depends on what your reference looks like. Use transmission, it's not enough. Then your rays are being scattered in the reflective part too, which is, I'd say, 98% of the time. All right, so a couple other things we add to glass. Under the advanced section in Arnold, we turn on caustics to kind of give that glass just a little bit more sparkle, especially when light's getting through it and on the edges. Now, thin-walled is used if we are modeling window panes for a building. Why? Because with a building, we want the glass in a building to be transparent and reflective, but we don't necessarily need to see the refraction. So the idea is, why calculate refractions if you're not using them? You just want the look of glass, and it will save you a ton of render time for big buildings, lots of windows. And besides, honestly, are you going to model every single little pane of glass with a little bit of thickness? No, you're going to use a plane for the most part because it's cheap and it's simpler. Unless you are working for a glass manufacturer, where it's critical that that little bit of refraction shows through. Then you're going to be working more towards a simulation than you will towards look development or making something look like it does in the real world versus making it exactly how it would behave in the real world. All right, any questions so far? Does that kind of make sense? Questions out there? Cody's good, thank you. Miles is good, Josh is good, thank you. Tamari's good, Marissa's good, Balin's good. Craig, questions? Patrick, any questions? Diamond's good, thank you. All right, Patrick is good, thank you. All right, so here are a couple of simple renders. Simple sphere, dome light, simple plane to catch shadows on. The very first index of refraction that I used on that sphere is air. Now, I know air does not generate a shadow, but if I did not have a shadow turned on that sphere, you wouldn't believe I actually had a piece of geometry in there. So it's purely there to represent shape that exists. All right, so air, you can see very neutral. Light does not bend, it transmits all the way through. Good example of transmission. All right, water, 1.33, you can see light bends and it becomes more reflective. This is just changing the index of refraction. You can see when we get up to glass, you can see how the light bends more, it reflects more. Get to a diamond, 2.42 or thereabouts, it's a lot denser. Consequently, it refracts light a lot more and reflects light a lot more. So the higher the number, the more the rays will bend as they pass through. All right, so we went over this in Maya already. So today we're going to worry about transmission in the top sampling section. Right, same as all the other settings where 2 to 3, that's kind of preview quality, 4 is medium, 6 medium high, 8 high quality, but be prepared for killer render times. Now, if you've got a render farm or you're rendering with a beast of a computer and you don't care, great, you can crank your settings up to the ceiling. Walk away and smoke and flames will happen and you'll come back, it'll be done. It'll bake in a nuclear oven somewhere. All right, and we talked about this area, right? We got the total number of rays. We've got the transparency depth, which is really high. That allows for air inside there too. But this is where we're going to need to increase the transmission and the specular. Now, volume, we're not doing any volumetric particles or simulations, so we don't need to worry about volume. Get into a visual effects class, that's going to be a whole other story. Yes, more or less, yeah, more for a simulation where you've got, with a gas, it's usually not unless it's super compressed, it's not solid. It's usually, for want of a better word, cloudy, where there's some areas that are more condensed than other areas. Yeah, that is what exactly it would be for. Also, think of it like this. Any movie you've ever seen, any game you've ever played where you go into a haunted mansion or a haunted building or just something really creepy, light rays coming in from the outside, you always have those God rays, right? You can see the light coming through as the light hits the particles. That would be a volumetric effect. Now, like I said, we don't do that because that verges on simulation. And right now we're just trying to get the basics. Now, there's many ways to do it. You can fake it. You can also simulate it. Depends on what you need and what the requirements are. Most of the time for computer animation or film, a lot of times, a lot of that is done in compositing. They will do that volumetric effect separately. Now, for a game, that's got to be done in game, and sometimes that's pre-calculated. Sort of like normal simulations, like fire or smoke. You know, you can just have a little cycle running, it's already calculated, and it generates enough variation in it where it looks random all the time. Now, as I mentioned, based on your camera angle, that can really change your render time because the camera is going to see things differently. So, seen above, this is actually before we were using denoise in RenderMan. The scene took me an hour and 6 minutes to render. The same scene, same settings. I got closer to the glass. I had glass overlapping now. Now it took me 2 hours and 11 minutes. It almost doubled my render time. That will do the same thing in Arnold. Not as much because we've got denoise that we can use, where it will clean up the noise. I didn't have to throw a billion samples at it to render it. But it's still going to take twice as long based on your camera angle. The more overlap, the more sampling it's going to need, and the longer it's going to take. Yes. Uh-huh. Yes. Particularly because that glass bottle is visible in the long shot, not visible in a close-up, although it could be in a reflection depending on what your materials are. There's also a wine glass on that same table with wine in it. You will, that's not like the top of the wine glass might be visible through one of the pillows. Not a whole lot, but that could easily be seen in a reflection. So we say generally, if it's questionable, it's better to put a material on it than have a black hole somewhere in your render. You know, when you're looking at it with a fine-tooth comb, and it's always your boss or somebody else who finds it. It's always like, you know, you spent hours, you're looking at it, and after a while, you don't see things anymore when your own artwork. So that's why you got to get away. You know, they come back and they go, and they'll zero in on it right away. Oh, look, you got a hole right there. It's like, ah, damn you, Maya. So again, depending on your camera angle, that will determine how long your render will take. So again, if you can see it, it needs a material. If you think it's going to be in a reflection, it needs a material. If it's questionable, it's better to put a material on it, make it a simple base material that, you know, is not going to take a lot of render time. But, you know, if it's reflective, make it reflective. If it's glass, you give it the base glass, just so it behaves like it should in your render. Now, that's only for, I would call it like a non-hero shot. Hero shot would be something that's directly visible in your scene, whereas a non-hero shot could be the top of something or a piece hanging out or visible in a reflection that's just there as fill. All right, so let me go through the process of making glass, and then I will take a screenshot of this and give it to you guys. But it looks pretty daunting. It's sort of similar to the way we did metal. If you follow the steps, you shouldn't have any problems making glass. And a lot of it is simple common sense. First, you got to find reference. You got to assign your material. You always want to start with metal or glass, turn off the base weight. The base weight off means no diffuse color will bleed into your glass, making it look milky. Keep your specular weight at 1. The color stays white. Those are both defaults. That's pretty simple, but it's there in case you ever get something from somebody else and they made glass and they messed with stuff and they didn't know what they were doing, which happens. So you adjust the specular roughness, transmission roughness. This could be done at this stage, or it could be done a little later, once you get all the other glass in there, or all the other glass settings. Adjust the index of refraction. It's already set for glass at 1.5. And then this is where we do our voodoo. This is to try and get Arnold to give us a shadow. This is where we plug in the gamma correct in the transmission that controls the transparency. We make a few adjustments in the gamma correction for X, Y, and Z. And then there's a section in the gamma correction called value. In that, we plug in what's called a sampler info node, which just means Maya is sampling that surface at whatever camera angle you're at. Plug that in, that gets connected. That will give us a shadow in Arnold. So let's see that in action. Let me set my project to project. Oh, you know what? I think I'm going to use project 5. No, let me see. Do I have project 6? Yep. All right, let me do this. I got the lighting done already because it's from project 5. All right, I'm going to use the day scene because it's what I demoed the other day for project 5. So here's my glass. And what I'm going to do is, let's see. There's the liquid inside the glass. So each object is going to get its own material, right? We already talked about this. Every object's going to have its own material. It's going to have its own material property. So for this, let me just make sure that everything is set up. Okay, that's good. Ray depths, that's default, good. Right, that's actually perspective. There we go. All right, so that's fine. So what I'm going to do is select my glass and assign a new Arnold material. Now, normally, which I should follow my own directions, find reference first. I want to find reference for a wine glass, and I want to find reference for a wine glass with wine in it, because that's going to be the geometry inside that we're going to use. So not only do I need to figure out the reference, but I also want to figure out, do I want white wine? Do I want red wine? Do I want pink wine? You know, Zinfandel, blush, whatever it happens to be. So those are the decisions you have to make because they are your choices, your creative choices. And let's go outdoor. And let's make it images. And anytime we're dealing with images, we want to deal with tools, and we want to have the largest size that we can have. And I don't like outdoors. Let's try outside. All right, now, a couple of things about wine in the glass. Yes, wine can be that dark, but for our purposes, we want to make sure you understand how to make something transparent liquid. So your wine, even if it's red, we need to be able to see through it a little bit. Something sort of like that. It can still be red, it can still be darkish, but not to the point where it's not going to let light through it. We need to be able to see through it a little bit. Like that would be acceptable. Although that looks a little hazy, it's probably been chilled. So you have to take all of that into consideration. So again, nice picture, but too dark. Can't see through the wine. The whole idea is to make sure you understand how to make it transparent. Dark, yet transparent enough where some light gets through it. All right, Balin said voting for red. Okay, noted. So how big is this? Yeah, that's a pretty big image. So let's go with this one. Kind of nice backlight. Let's see if we can save this image. Let's see. JPEG. So far, so good. Might work. All right. Yep, that would work. All right. So I'm taking a look at this and I'm saying, okay, there's my wine glass, pretty transparent. The photographer's using some depth of field, so everything is blurred out, but what he wants you to focus on, or she wants you to focus on. So the wine does not look very hazy or rough, neither does the wine glass. So really good wine glasses, really good wine is going to have a very low level of roughness in it. Unless, of course, you're serving, like you've got reference with white wine, happens to be chilled, and there's condensation on the glass. But for this, that's pretty clear. All right. Let's go back to Maya. So here, got my reference. Select my object. Let's assign a new Arnold AI standard surface. Wine glass. Again, name as you go. All right, for the base weight, that's going to be 0, off. Okay, base weight off. Specular weight and color are the default down here. Perfect. White. The weight's 1. Index of refraction 1.5. Check. Good news so far. Roughness, I'm going to hold off on the roughness until I get the rest of my glass built. So now, let's just make it simple glass. I'm going to turn up my transparency, which is my transmission weight. And honestly, I'm going to leave everything else. Well, I am going to lower the specular roughness because the default is usually pretty high. All right, so let me delete all these images that we talked about earlier. Let's save that. Let's render this. All right, so now I have transparent glass. Notice anything about my shadow all of a sudden? Yeah. That's what happens with, unfortunately, the standard Arnold material. When you do not account for how the transmission is being handled. All right, so this is one of the shortfallings of Arnold. Everything else is pretty simple. It works pretty good. You got to make your own shadows for glass, or basically we're telling the material to behave correctly to give us glass shadows. So now the only shadow that I see in here right now is a shadow from that piece of clay sitting in my glass, which is basically that standard surface diffuse gray color. Now, in order to get proper shadows, this is what we have to do. So we need to click on the transmission weight input right here. Now, transmission weight input will give us a create render node. Right? We want to go in the Maya utilities. Let me go back here. So Maya utilities, they're alphabetical. So we want to go down to gamma correct under G. gamma correct. So then you get this scary connection editor, but don't let it scare you. It's not that scary. All right, so on the left, down at the bottom under value, we're going to go out X. And on the right side, we want to hook it up to transmission. So now we're hooking up the out value of the gamma correct to the transmission section of our material. Click close. Here's our gamma correct right here. Next, we want to change the gamma to be 4 in X and 0 to be, these are X, Y, and Z. So Y and Z are going to be 0. We want to have 4 set up for X, 0, Y, 0, Z. We're not done yet. One more thing to do. Under the value in our gamma correct, right here, we're going to plug in one more utility. Again, a Maya utility. This is going to be a sampler info node, so it's under S. Sampler info, right here. So here we're taking the facing ratio, which is the camera, looking directly at the object. Wherever that camera is looking, that's the facing ratio. And we want to plug it into the value X of our gamma correct. We hit close. Now, if I hit the render button, I get a shadow. So this is without the gamma correct and sampler info node. This is with the gamma correct and sampler info node. We're not quite done yet because that shadow is a little bit dark and there's a couple other things we want to do to the glass. So that's the base fix. Let's go back to see what else we have to do. So transmission color, if you leave it at white, that is clear glass. Most wine glasses, in fact, wine glasses for our purposes for this exercise are going to be clear. That's part of the directions that we have. So we can leave it the default. Next, we're going to go to advanced, turn on caustics, and we're going to do something called increase the indirect specular light. All right, so let me stop that. Let's select the material. You can see we've now got our connection in the weight. We go down to advanced, down here. We turn caustics on. Indirect diffuse, we're going to bump that up to 1.1. That will push the indirect diffuse. Well, wait, I'm sorry. My bad. It's specular. Keep saying diffuse. It's the indirect specular. We want a little more reflectivity. That's going to push the reflectivity along with caustics to give us just a little more sparkle in the glass. So now if we render, this is before we adjust it, we added caustics and we increase the indirect specular. So now it starts to look a lot more like glass. Doesn't affect our shadows, but it affects the direct light on the glass. All right, so for us, then we would go in and start to adjust the render settings if we need to. Honestly, we don't really need it yet. Why? Well, because the ray depth here has a transmission of 8 already. Now, I could bump up specular at this point. So let me stop that. Stop. Go back to 1. I want to save that. And that's clean enough. Okay. So now I want to crank up my specular to 8. So once I pump up that specular, the number of specular reflections, you can see that it really helps to push the glass now. Now it looks like a glass on a really bright day. Now, since we're not doing window panes, we don't have to worry about turning on thin because we want the glass to have light rays that bend as they go through. So Christopher Moulton said, or click present and then click glass from lists. Click replace from it. Are you talking about presets, Christopher? We do not use presets. All right, so just to clear that up, yeah, there are presets, but what do you learn from them if you push a button? If you have to adjust them, which 98% of the time you're going to have to, because you can't just use a preset and walk away. It's usually got to be customized in some manner. Yeah, presets are great if you're doing a really super quick concept. Proof of concept. So yeah, great. Lots of really cool presets. In fact, I would recommend use a preset, learn what they did to get that look, but understand what it is that they did. That's really part of what we're trying to push. You can't make a career on presets. So lots of great presets in everything. There's presets in Unreal, presets in Unity, presets in Substance Painter, Substance Designer. You name it, there's presets, but you have to go beyond the presets. Okay, so good point, actually. Thank you. So let's continue on. So at this point, this is where we would want to make wine. So first thing we're going to do, select our geometry. We've already got reference. We're going to assign a material to the wine geometry. Shift T. AI standard material. I'm going to call this red wine. And we're going to do exactly what we did to make glass. All right, so base weight goes off, spec weight, spec color stay, roughness, we can adjust that after. Index of refraction, this is where we're going to have to figure out what is the index of refraction for wine. Because it is not glass, it's a little bit different. Water is 1.33, glass is 1.5, wine's got to be somewhere in there. All right, so that gets turned off, that stays. Now we need to find out what is the index of refraction for wine. All right, Simply Maya, yeah. Let's see what they have. A lot of CG websites will have lists. Use them cautiously. Here is an excellent resource. And unfortunately, I believe they took that website down, but this will kind of give you an idea of where the red wine is. So you can see it's 1.33, but 8. Between 1.338, well, that's white, 1.339. Okay, that's 1.339. Here's one that's 1.337. So red wine can go anywhere from 1.337 to 1.339. And that is wine apparently at, I guess, room temperature. When they start to lower it a little bit, it looks like the index of refraction changes ever so slightly. So I would say here 1.7 to 1.9, over here, or 1.337 to 1.339 over here. At 20 degrees centigrade, it's 1.337, 1.338. I'm going to choose 1.338. That seems to land between everything. So white wine, red wine, looks like you could get away with 1.337, 1.338, 1.339. I'm going to choose 8. All right, so I'm actually going to take a screenshot of this. Okay, so that helped. So here, index of refraction, 1.338. Seems like a little kind of minuscule change from water, but every little bit helps. Okay, so we got the right index of refraction. We're going to do the exact same process for the wine that we did for the glass. We are going to use the gamma correct and sampler info so our wine shadow is accurate. Now, you will get a wine shadow because Arnold apparently will make a shadow for everything other than clear glass. But it still is a little more accurate when we go through the entire process. So first thing we're going to do, let's add in our gamma correct. That goes in transmission weight. Come down here, utilities. We go to gamma correct. In here, we go out value under X. and we hook it up to the transmission section of our material. Click close. Now we're going to change our gamma X to 4, Y 0, Z 0. One more thing, we're going to hook up our sampler info to the value. So again, utility, it's alphabetical under S, sampler info. We want the facing ratio of our sampler info. And we want to hook it up to the X in our value. So that's all hooked up. Now our transmission color, this is going to be based on our reference. So for the color, I could try sampling it like I did the other day. Let's see, can I get this to sample? Let's see. So transmission. Now you want to avoid, again, really dark areas. And you want to avoid super white areas. We're just going to go with this. We want to go down under advanced, turn on caustics, increase the indirect spec. So our material, we want to go down to advanced, turn on caustics, indirect specular, 1.1. So now we have wine. It's a little on the light side compared to what I have on my reference. So this is where I can go in and adjust my color. So you can see I got my value. That's pretty high. I'm going to lower it a little bit to kind of deepen that red color. Now, as you lower value in color, you are also kind of killing the transparency. So you have to be really careful if you make something super dark. It's going to kill the transparency. Saturation, a lot of times if you have a wine with a very subtle color, liquids, glass can oversaturate really quickly. But that's pretty saturated, that color. Just turning the value down. So now we got a kind of a nice little look for our glass. Now, as far as ray tracing or as far as our ray depths, we're still pretty good because our glass with the wine in it only takes up 6 rays, right? 4 for the glass, 2 for the wine. Oops. All right, so here is the $1 million question. Let's do this. This bottle is empty. How many surfaces do we need to go through for the bottle alone? 4, exactly. So Cody's got it. Miles has got it. All right, so we got 4. So altogether, we've got a total of what? You got 4 for the wine glass, 2 for the wine, 4 for the bottle. Pretty simple, 10, right? How come the wine completely flips the image in a reference? Because it's reflecting off the bottom of the glass, I believe. Is that achievable in a render? That's a good question. Let's see. It should be automatic. Let me keep that for now. Let's go to perspectives. It's going to be kind of hard to see because we got a lot of other stuff going on there. Let's see. Let's change our angle a little bit. Now, one thing I didn't do is I've got my roughness in my wine turned up way too high. So that should help with some of the reflections. It sort of looks a little bit like, here's my sky here in the reflections. So yeah, I think we're actually getting the same results. It's just that we don't have the same lighting and scene setup. I mean, you're the first one to ever ask that because it usually happens automatically, even in CG. Sometimes though, photographers are tricky. They may put a hidden mirror at the bottom so it flips everything again when you look at the reflection. And that's what I was kind of looking at down here, but it just looks like a wooden top on it. So yeah, I think we're getting the same thing. It's just not as pure as what we have there because we got a lot more going on. But yeah, that's a good question. Cool. Let's stop that. Let's go back here. There we go. So looks like we did everything. One thing I do want to check though, did we go down to advanced and we turned, yep, we did everything for the wine. So we're set to go. The only thing we're going to need to do is we're going to do the bottle. The bottle then is going to make us turn up the actual render settings in the ray depth. All right, so let's get first off reference for the bottle. Now, wine bottle has to be a color. So you can have either, there's usually green, dark green, light green, amber color bottles. So but it has to be empty. Windy bottles. No, wine. All right, so not bad. Some of these are beer bottles, and nothing but the finest screw-on lids for our wine. Even though it doesn't really matter whether your bottle in the reference has a screw-on cap or not, we still have a cork in ours, which you're going to need to find reference for a cork also. So we can have kind of this olive green or light green color for the wine bottle. Avoid anything that's had a wine bottle dissected and used as a light. Right, so those are all good. I'm going to pick my tools. Let's make sure the size is large enough to use. There we go. All right, so same bottles that we had here, different angle. Yeah, no super dark wine bottles. Most of the super dark wine bottles, Balin, are probably filled and new. So our bottle has to be empty and we have to be able to see through it a little bit. Now, technically, we could use this really dark amber bottle because I have seen wine bottles like that. Even though that's kind of got the old school reusable cork on it. It's not a cork, it's ceramic with a rubber ring. Yep, Miles reminded me I forgot to set my size. Yep. Good, thanks for catching that, Miles. All right, so yep, let's go with this one, see if we can grab it. Empty wine bottles, table. All right, so first thing, we found reference. Let's assign, before I forget, the wine bottle has a label around the outside of it. So one thing that we want to do is take that label and put it onto a display layer. All right, so let's see real quick. Let's go to preview. All right, so through the miracle of modern editing, I am now back on the website. And let's take a look at our requirements for glass. So we're doing the exterior now, so I'm going to shoot down here. So AI standard, okay, wine glass, we did. The wine inside there, we did. The wine glass is clear. The wine in the glass needs to be a colored liquid. The wine bottle needs to be colored liquid. The wine label, you're going to take that geometry, place it on a display layer, and turn it off. We are not worried about a label. All it's going to do is cover your wine bottle so we can't see through it. So most labels are whitish or some other color. What's the point of having a label wrap around the bottle that looks like it was a paper bag? When we get into project 7, if you decide to do this scene, we're going to show you how to actually cut the shape of your wine label out, and it will get rid of the rest of the geometry. So for this, take the wine label, put it onto a display layer. You guys have done that in modeling. Wine label. Let's save it and turn off that display layer. So now we're dealing with just the geometry. All right, so got reference. Let's assign that new Arnold material. Right now it's got the default. Put that over here. And there we go. The reference images have to be JPEG. Doesn't matter whether it's JPEG or PNG. You're going to be putting them into a collage at the top of your reference area in your template. So doesn't really matter. As long as it looks good. I would stay away from GIF files, GIF. They're terrible. Okay, so new Arnold material, wine bottle. We're going to do the same thing we do for all the others. The weight goes to 0. Roughness. These don't look super rough, but I'm going to give it a little more roughness than, say, the wine. They don't look too bad. Can always come back and adjust the roughness later. So specular weight, color stays the same. Index of refraction, it's glass. We're keeping that the same. We want to make sure that we put in our gamma correct with the sampler info so that we get a shadow. All right, so that goes under transmission weight. This is where we map in our gamma correct. So Maya, utilities, gamma correct. In the connection editor on the left, this is our gamma correct. We want to choose the out value X. This is our material on the right. We want to plug it into transmission. Click the close button. Inside our gamma correct, we want to change our X gamma to 4, Y to 0, Z to 0. Last thing we do is in the gamma correct value, this is where we plug in our sampler info node. So again, create render node, Maya utilities, it's alphabetical under S, sampler info, connection editor. This is the sampler info. We want the facing ratio, and we want to point that at the X value of our gamma correct. So now we should have a wine bottle that's clear. All right, now, this is where we're going to sample our color in. So now, do we want to have light green, dark green, amber? Wine bottle color. So dark green, dark green. Okay, you're talking about this one right here in the foreground, right? Dark green. Olive? Yeah, okay, that works good. Let's do that. All right, so in Maya, the last time I did this, I selected my wine bottle. went down to transmission color, clicked on the simple color picker and sampled it. This time I'm going to double click and bring up the advanced color picker. So transmission, double click on color, brings up my advanced color picker. I'm going to load my reference here in the center under color wheel, image, click load. I've got my reference sitting on the desktop right there. And now all I have to do is left click and let's find a nice color. I want to avoid a really bright area. I also want to avoid a really dark area. So let's get kind of a neutral area. And you can see this is probably going to be a lot more yellow than we think. It's got a lot of yellow in it. Well, let's try that and see what we get with that. It's all trial and error. So now when I hit the render button, it's really super dark. In fact, it almost looks like that. So there's a couple things I'm going to do. One is going to click done for now. I want to make sure I go down to my advanced section, turn on caustics. I want to bump up the indirect specular. And now I'll go back and adjust my color. So for one thing, the value is super low. Just because you sampled it and it looks like it doesn't mean it shows up that way in your render. So value, honestly, I try and keep mine over 0.7. So let me start at 0.7. Not bad. Looks like it's a little bit on the, maybe it does need to be a little bit darker. Looks like it's more on the orange side. Let's put that a little more towards the green. So right now what I'm trying to do is, just because I sampled it doesn't mean it actually sampled the right color combination that I want. That was way more orange than I wanted. I wanted it to be more towards green. So I took my hue, dragged it up to the green. So that's a whole lot closer than it was before. All right, now, so I'm going to stop this. Let's save it. And the last thing I want to do is let's go and check the render settings. Because now I've got 10 surfaces that my rays need to go through. So here, 10, that's cool, 10. I want to crank up my specular and my transmission both to 10. Transparency depth is already there. And let's render. So just a little bit here, that kind of reflection. We're going through the wine bottle. Does that make sense? Any questions so far? Everybody good? Okay. So let me pull this up and let me take a screen of this for you guys. And let's drop that in the chat here. All right, this is a good time to take a break. When we come back, we'll do the interior. I'm going to show you guys how to turn on the glass geometry for the windows in the interior because you need to have glass on. We're going to make those into window panes. And then we're going to do, well, we'll do at least one of the bottles that we have in there just to show you guys it's the same process, whether it's interior or exterior for making glass. And then have you guys do some work on your own, see if there's any issues. All right, so I will see you guys in 20 minutes. So let's come back at 11:15.